Hello and welcome everybody to the next day in our series of Rust in 7 days. Today we are going to be looking at threads. And in our first video, we are going to be splitting a program into threads. Doing this isn't actually very tricky. We can write something like let h equal and then spawn, which creates the new thread. And this is a function which takes a function as a parameter, what it's actually going to do. And you can write this as a normal function, or we can use closures. Closures are good because you can kind of include the data within them. So that's what I'm going to do here. So this is the list of parameters that a closure takes. So we could say the function takes a and b as parameters, but spawn requires a function that doesn't take any parameters. So we have to match those requirements. And this is what the function will do. So it's very easy to just write code that will act in a different thread. And now let's write for I in 0.10 print line, and we'll print I. And here we can write for I in 10.20, and we'll have something similar, print line I, print line done. And of course we need to use spawn, so that's standard thread spawn. And here you'll notice that the program has only ran the latter part of that. We've not seen the print line from the others, because when the program reaches its end, all other threads are finished automatically. But if we don't want that to happen, then we can call h.join, and that will wait for the first thread to finish before completing. So the h represents a handle, a means of pointing to the other thread and waiting for it to complete, and when it completes we get a message. We can actually do better than that, because h.join returns a result. We can pull information out of that result. So what if our function here, for example, was to return 5? It's kind of arbitrary, but this is a return for our function here. And we can pull that out with unwrap or any other error handling mechanism and let r equal. And here we can put maybe r equals and put r there. And now when we run the thread, we end up with a result that says done r equals 5, which means it successfully pulled back the result from running the separate thread. Now every time we run this so far, we've always finished the one thread before the other really got to get started. So let's perhaps make the one run a little bit slower. Standard time duration, and we'll use standard thread, and the method is called sleep. And in each of these we will put sleep, and then it's duration from milliseconds, and we can say maybe 10 milliseconds to wait. And we can put that in here as well. And now when we run the program, hopefully we'll find that the two sets of numbers interlace as they both wait and take it in turns. But it's not a complete interlace because, as you see, the 18 and 19 both managed before the 9. We can maybe make this 20 and see a slightly different pattern in the gap.